Hello friends, this is Road to IIT and this is my second video on the chapter Thermodynamics. Okay, we are start the physics and we started with the Thermodynamics chapter. So let's get started. So first of all, today we in the previous video we saw the first law of thermodynamics, and that we see in the last that the sign conversion which is going to be used in the first law. See, sign conversions have two types there. One is we are using for physics and one in chemistry. There are different sign conversion there, but see the different rules are there also. If you are going for the physics sign conversion, then you have to use this rule: delta U is equals to Q minus W. That means Q is equals to delta U plus W. But if you are going to apply the sign conversion of a chemistry, then you have to use Q is equals to delta U plus W. Q is equals to delta U minus W. That means delta U is equals to here Q plus W if you are using the chemistry sign conversion. That means the sign conversion is a critical thing to understand. So today I am going to just clear all your doubts and we are going to move forward. So first of all, let us talk about what is work done, because in the first rule we have three properties there. First is work done, second one is internal energy, and third one is the heat. So what is work done? First of all, if we have PV diagram here, and this is the process, this is my process, we are moving to the A to C. So as we know, the area under the curve of a PV diagram tells us the amount of work to be done. See here you can see V1 to V2, the volume is going to increase from V1 to V2, and if we take the area under the curve, that means the V is my variable, that means dV is a variable, limit is from V1 to V2, and P dV, that is work done. So limit from V1 to V2, P dV is, this is the common basic formula for each and every type of process. The process is changed, the final formula is going to be changed, but the basic formula is this: area under the PV curve of any processes. Now the sign conversion, this is sign conversion we are going to use for whole thermodynamics topics in the physics. If there is an expansion, because in the physics what we expect from the machine, that we have some work from the machine. That means work done by the system. Work done by the system is beneficial to us. That means we take that as a positive. So expansion, work done by the system, volume increase, we take that as a positive. And a compression, work done on the system, we take that as a negative. And the chemistry, the sign conversion is just opposite to this. That means if there is an expansion from there here to here, you can see sign like this. So the volume is going to be expand. So the work done is positive. And in the compression, if the volume is going to decrease, then the work done is negative. Okay. So this is for work done. Now, what if there is a cyclic process? Cyclic process, that means initial and final stage are same. That's called a cyclic process. Any process in which system returns to its initial stage after undergoing a series of change is known as a cyclic process. Okay. Now, then what is the work done? If there is a cyclic process, then the area bounded by the curve is my work done. So here you can see this all area. These areas are my work done. But there is also sign conversion. If the work done is anti-clockwise, see here it's anti-clockwise, then it's negative. And if it's clockwise, then it's positive. See how this could be possible. That is, it is positive and it is negative. See here, first of all, let us see, I am here and I am going from here to here, then again back from here to here. Then if I am going to expand this, that means work done is positive. So area under whole this whole area from this to this is my final answer, and that is positive. Then I am going to subtract this much of area under area between area of this curve, the down curve, that is small value compared to the upper one, and that is negative. So the final area is positive for that. And if I'm going for this direction, from this point to this point with this direction, and then this to this. So that means here the larger area is covered by the decreasing volume. That means a negative part. So the volume is negative here. Understand, this is a very basic concept. If you don't want to understand that, just remember this thing. If the cycle is clockwise, then it's positive. If it is anti-clockwise, then it's negative. Simple. Okay. Now, again, first law. Okay. First law again. According to the first law, we know that the change in internal energy, or we can say that a heat energy generated is the sum of internal energy plus work done. Okay, Q, heat is equals to change in internal energy plus the developed work done. Okay, this is thermodynamics. This is nothing but energy conservation rule. Energy conservation rule, that energy neither created nor destroyed, it just transferred from one form to another form. Again, the sign conservation very important. Head is given to the system, that's positive sign. Lost by the system, negative sign. Work done by the system, positive sign. Work done on the system, that's again a negative sign. Important thing is a sign conversion, so please remember this. Okay. Now the next thing is heat, because heat is also important property. What heat? We just saw this in the previous video, but again, heat is the transfer of energy between the systems. Heat is that energy in the transit phase. We can say that like this. Unit is joule. We can represent it as Q, delta Q, and dQ. Again, sign conservation. Heat absorbed by the system, that's a positive. Heat given out by a system, that is negative. Okay. Okay. This is a most important thing. See, and according to the first law, we have to know some values of delta Q and delta U, the energy, internal energy, and Q. For that, we have to learn a specific heat. What is specific heat? A molar specific heat of a substance is defined as the amount of heat required to raise the temperature of 1 mole of the substance through 1 degree. Take denominator quantities as a 1 unit. So here N is a mole. So take N as a 1 mole and delta T as a 1 unit. That means amount required to raise the 1 mole of a substance by a 1 unit temperature. Okay, this is the amount of heat required to increase the temperature of a 1 mole by 1 unit. A simple definition. And the unit of this specific heat is delta Q, that's units is joule. For N, that is mole, and for delta T, it's Kelvin. If there is a mass specific heat, then we can say here it's a mass, that is M, and here in the space of mole we have kg. Okay. Now, two types of specific heats are there: at a constant pressure and at a constant volume. That is specific heat at a constant volume, that's denoted as a CV. Okay. And definition, again a same definition, but here you have to use the word that a delta Q at a constant volume defined as the amount of energy required to raise the temperature 1 mole and a substance of 1 degree by when the process is constant volume. Just add this line and the definition comes. Okay. Sorry. Where you can see CV is specific heat at a constant volume, delta Q heat energy transferred at a constant volume, and as a number of moles. Same thing, delta T is a temperature difference. Again, definitions: constant pressure. See here the process is constant pressure. Formula is almost same. Quantities are same. Easy thing to remember. Delta Q, you can say that as a NCV delta T. That's the formula of internal energy. So this is all the things that we have to remember before solving the problems. Okay. See, in the physics, the theory is a very important part. So we have to cover all the theory portion. So this is all about today's video. In the next video, still I am going to cover a small part of theory, and then we are going to start solving the problems. So this is all about today's video. Please keep watching. If you like this video, don't forget to share it and hit that subscribe button. Thank you.